Hey guys, welcome back. Today we're going to discuss limiting versus excess reactant. So we're going to start with problem 1. Here's our reaction, and we have to first balance the equation. We're going to do so by first balancing out the hydrogen on the left. We have 2 hydrogen on both sides. Then we need to balance out the bromide by changing this coefficient from 2 to 6 and changing this coefficient from 1 to 2. We now have 6 bromine on the left and 6 bromine on the right. However, we have 6 hydrogen on the left, meaning we need 3 H2 or 6 hydrogen on the right. Lastly, we have 2 aluminum bromide on the right, aka 2 aluminum on the right, and so we need 2 aluminum on the left. Now that we've balanced our equation, let's look at the problem. When 86.9 grams of aluminum reacts with 401 grams of hydrogen bromide, how many grams of hydrogen gas are formed? So, the first thing we're going to want to do is write out our problem. So, in order to find the limiting reactant, we first need to convert both 86.9 grams of aluminum and 401 grams of hydrogen bromide into moles. In order to convert these elements and compounds into moles, we need to multiply them by their molar mass. For aluminum, we will multiply 1 mole of aluminum over 26.98 grams. For hydrogen bromide, we will multiply 1 mole of hydrogen bromide over the mass of hydrogen plus the mass of bromide, which will equal out to about 80.912. Now that we're going to convert into moles, we must be ready to convert from moles of aluminum and moles of hydrogen bromide into moles of hydrogen gas. We will do that with the molar ratios. Now that we've multiplied by the molar ratios, we need to make sure that we convert to grams of the problem mass. Now we can simply plug this into our calculator. Now that we have found the amount of grams of hydrogen gas, we can tell that the limiting reactant is the one that produces less. In this case, that means the limiting reactant is hydrogen bromide. This also means that only 5 grams of hydrogen gas is produced, since obviously you're not able to produce 9.74 grams if you only have the aluminum. Now let's talk about the excess reactant. Since we've determined that hydrogen bromide is the limiting reactant, we know that aluminum is the excess reactant. In order to determine how many grams are left at the end of the reaction of the excess reactant, we can start off by subtracting the values of grams of hydrogen gas that each produced. Now that we know that there are 4.74 grams left over, we can calculate the grams of aluminum that are in excess. Let's start by converting these grams back into moles. Once we've converted it back into moles, we can use the molar ratio between hydrogen gas and aluminum. Finally, we can convert the aluminum back into grams. Now all we have to do is do the calculation, and we get about 42.29 grams of aluminum. Let's try another problem. The first step is to balance our equation. Since we have 1 silicon on the left and 3 silicon on the right, we're going to need a coefficient of 3 silicon to balance this equation. Since we have 2 nitrogen on the left and 4 nitrogen on the right, we're going to need a coefficient of 2 to balance this equation. Now that the equation is balanced, let's look at the problem. When 602 grams of silicon reacts with 494 grams of nitrogen gas, how many grams of silicon nitride are formed. So first, let's convert to moles. Now that we've converted to moles, let's use our molar ratio between the reactants and the products. Now that we've used our molar ratio, let's finally convert to grams. Now, we can simply plug this into our calculator to find the answer. As we can see, the 602 grams of silicon produced less silicon nitride than the 494 grams of nitrogen gas. Therefore, silicon is our limiting reactant. Since nitrogen gas is our excess reactant, let's try and figure out how many grams are left over. To start, we're going to want to subtract the amount of grams of silicon nitride that the nitrogen gas produced by the amount of silicon nitride that the silicon produced. Now, we're going to convert back into grams of nitrogen gas, starting by converting into moles. Now that we've converted into moles, let's use the molar ratio between silicon nitride and nitrogen gas. Lastly, we need to convert from moles to grams. And now we just have to do the calculation. And we end up with 93.95 grams of nitrogen gas. Thanks for watching. Like and subscribe.